Hello there, I'm Thomas Hatsios, the British American pilot flying the Boeing 777-300ER into flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport runway 1449 Lszh localizer landing. So now I'm in the cockpit for the pre-takeoff preparation of the PMDG simulation and Microsoft Flight Simulator X. Boeing 777-300ERX. I'm gonna start showing you the cockpit instruments, the displays, and the functions of the Boeing 777-300ER jet aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the ground speed, the airspeed selected from the autopilot and flight director panel, the magnetic heading and track, the magnetic north pole and true north pole, and the magnetic variation depending on where we are in the world. We have the radio altitude above the ground level, the altitude indicator with the pitch ladder in degrees and the bank angle in degrees. Also we have the Lszh localizer and the flight director crossbars for manual guidance of the aircraft. We have the autopilot crossbars for automatic guidance of the aircraft. We have also the barometric pressure of the outside atmosphere. We have the barometric altitude above the sea level and the target altitude selected from the autopilot and flight director system panel. We also have the vertical rate of climate descent of the aircraft in tens, hundreds and thousands of feet per minute. The vertical speed indicator over here, as you can see. We have also so we have also the target altitude selected from the autopilot and flight director system panel, the angle of attack of the aircraft as it flies, the flight mode annunciator with the autopilot and the autothrottle, later on vertical navigation modes, and we have also the vertical speed indicator with the vertical rate of climb descent of the aircraft that determines also the steepness of the angle of the aircraft can climb or descend. Also we have the navigation display. The navigation display that displays the airports, the waypoints, GPS position of the aircraft. We have the inertial reference position. We have also the magnetic heading and track, the magnetic north pole and the true north pole, and the magnetic variation depending on where we are in the world. We have the airports around our own aircraft, the distance they are located. You can see other aircraft flying around our own aircraft, the distance they are located, their direction, their altitude difference, and their airspeed and the traffic collision and alert system. The TICA system generates the warnings about the other aircraft which are coming. So we have the transporter, ADSB and ADC transmitter receiver that transmits and receives our own frequencies and from other aircraft and generates all these warnings about the air traffic. You can see in the navigation display. We have also the weather radar and with the terrain reflection, you can see. So we have the terrain and weather reflections over here in the navigation display. We're gonna set up also a flight plan using the flight management computer. We're gonna input all the waypoints, the departure, airport and runway, the data of the aircraft for takeoff. We're gonna have the takeoff weight that includes the empty weight plus the passenger plus the cargo plus the troop fuel plus the reserve fuel plus the tax fuel plus the runway data for takeoff, like the runway length, the slope of the runway, the runway conditions, if it is dry, wet or ice, the wind direction and speed, also the barometric pressure and density of the air and the temperature of the air. And we're gonna have also the flap settings of the aircraft for takeoff. We're gonna set the flaps for takeoff, and also we're gonna make a calculation about the mean aerodynamic chord through the center of gravity of the aircraft, and the horizontal trim stabilizer also is gonna be calculated in degrees for the horizontal trim stabilizer settings for takeoff. So we're gonna have all these things here displayed. We're gonna see so also we're gonna create a flight plan using the flight management computer. I will show you also that. We're gonna input all the data for takeoff, like the departure, airport and runway, the seats, the other instruments, departure, waypoints and fixes, the climb and cruise, and the descent and intermediate waypoints, also the destination, airport, standard terminal arrivals for the stars for the destination, runway and airport. And we're gonna have also the Lszh localizer, horizontal localizer and vertical glide slope frequencies set for the desired destination, airport and runway. So we're gonna have a complete route or a complete flight path using the flight management computer over here. You can see, and we're gonna use the flight management computer to input all the data that I told you before. So we have the primary flight display with the flight mode annunciator, the navigation display, the flight management computer, the autopilot, flight director system panel, the upper and the lower ACAS engine indication equalizer system display, the thrust levers over here. You can actually the thrust. So I will continue with the autopilot and auto throttle. Autopilot and flight director system panel. I will show you the auto throttle, left and auto throttle, right, engage and disengage switch, the autopilot on and off, engage and disengage switch, the flight director engage and disengage switch. We're gonna select an airspeed using the airspeed select node, and we're gonna have the mode for the airspeed command for the thrust using the engines, the jet engines installed in this aircraft. We have General Electric 90 turbofan turbojet engines, since this is a jet aircraft, a jet powered airliner aircraft. So we're gonna have also the airspeed select in nautical miles, knots or Mach, and we're gonna select the modes like the flight level change, climb continuous or auto throttle, hold with the speed mode. So we're gonna have two main modes of thrust commanded by the engines using the FADEX. The FADEX are the full authorities electronic control computers installed in our gearbox of its engine, left and right wing engine. We have one FADEX to control the engine's functions, so I will show you also that. So the FADEX controls and monitors and displays all the data you see here in the upper and the lower ACAS engine indication equalizer system display. Also, when you move the thrust levers forward or aft, the thrust lever position or the thrust commanded by the autopilot and auto throttle. So you're gonna see this also. So we're gonna select, and we're gonna have two main modes, like if we climb or if we descend. We have the maximum continuous thrust for takeoff, go around or climb, or the idle thrust for descent. So in either case, the thrust is being held constant, fixed thrust mode, and we have the airspeed being adjusted as the aircraft climbs or descends by varying how fast the aircraft climbs or descends in tens, hundreds and thousands of feet per minute, or at trigonometric angle in degrees. So we have the fixed thrust mode, and the airspeed is varied like this by giving orders to the horizontal trim stabilizer, the auto trim of the horizontal tail, or the elevator of the horizontal tail of the aircraft to maintain a climb or descent path. So I'm gonna show you that. We have also the variable thrust mode, which is the other main mode of the engine's function, in which when the altitude of the aircraft in flight has been held constant flight path like in the cruise level or in the approach and landing. The airspeed has been varied by varying the thrust produced by the engine. So I'm gonna show you also that. I'm gonna show you the LNAV and the VNAV, the lateral navigation, the vertical navigation of the autopilot and flight director system panel, which is interconnected with the flight management computer. Inputs for the lateral and the vertical navigation. I'm gonna show you also the angle hold switch for the cruise level, the heading select knob and the heading hold switch, the vertical rate of climb, the descent of the aircraft mode, the VS mode or the flight path angle, the FPA mode, which determines how fast the aircraft climbs and descends with 10,000 feet per minute or a trigonometric angle in degrees. And the hold switch for these modes. I'm gonna show you also the altitude select knob and the altitude hold switch. I'm gonna show you also the VOR localizer and the approach with the auto land function. So this is gonna be the main functions of the autopilot and auto throttle systems. I will show you also the thrust levers, as you can see here. I will show you also the overhead panel, the electrical, the left and the right engine drive and IGC, the grid drive generators, the APU, the batteries. I'm going to show you their data and also reference unit, the primary flight control computers, the hydraulic system, the left and the right engine driving, the rammer turbine, the passenger oxygen, the engine, the cargo fire, the electronic engine control for the engines, the fuel jettison, the fuel system, the left and right wing, and the center tank fuel system over here with the fuel booster pumps and the crossfeed valve. You can balance the fuel between the left and right wing using this crossfeed valve. Also the hydraulics over here, the cabin pressurization and the bleeder from the left and the right engine, and from the APU we need bleeder for cabin pressurization, wing and engine advice, air conditioning and ventilation over here, and the hydraulic fluid pressurization. Also we need the pressurizer for starting the engine section here using the APU. So I'm gonna start later the APU. The APU is a small auxiliary power unit in the tail of the aircraft. We're gonna use for starting the electric power and the pressurizer we need for starting the aircraft. I'm gonna show you then also the flight controls here. You can see the control column and the control wheel, so we can climb and descend the aircraft using the horizontal tail or bang roll left and bang roll right, using the ailerons and the spoilers in the left and the right wing, and also use the rudder pedals for directional steering using the vertical tail, the rudder of the aircraft. Also we have the nozzle steering for the ground, and here's the horizontal tail trim stabilizer. You can set the horizontal tail position in degrees, and you can watch how many degrees of horizontal trim stabilizer you have here. Also the trim tabs and the disconnect switches for the auto trim. So I will talk to you now about the flight controls of the Boeing 777. Also you have to high control them using the side stick. I have the Logitech Extreme 3D side stick here, so you can see. I will show you now. I use this Logitech Extreme 3D controllers, so you can see here. I hope you can see. So you can see I can control the side stick position. I move the control column forward and aft, or I can move the horizontal tail elevator up and down like this for climb, or for descent like this. So you can see the side stick deflection is proportional to my yoke deflection. Also both sides, the left and the right, are interconnected to move simultaneously. When I give a command for change the attitude of the aircraft. Also the rudder pedals over here, I have control of the rudder pedals same way. Simultaneously we have full flight control. So we have over here the thrust levers, as you can see. I can increase or decrease the thrust position like this. So this is for the flight controls, full control. You can see the side stick deflection is proportional. The yoke, I have full takeoff ground power now. So it's easy to control. It's also easy to set the horizontal trim stabilizer like that of the aircraft. So also you also the outside view doing the same thing, using the side stick for the flight controls, deflection and control. So also you know how to do that also. So you can see here we have the flight controls. We have the speed brakes extended, which also act as flight direction flag. So you can see over here we have again the side stick deflections here, climb, descend, bunker left and bunker right. We have full flight controls. Also the rudder, the vertical stabilizer like this. So you can see the elevator for climb and for descend, the tail of the aircraft, and also the wings are left and right, and the rudder full left and full right. So I'm gonna show you now inside. You can see the side stick deflection is proportional to the deflection. So we will move to the next section now, show you the controls. So thank you very much one more time for joining me in this video. I'm Hatsios, the German-American pilot flying the Boeing 777-300ER international flight. So I'm gonna start now. I will also make a complete engine start demonstration here up the flight management computer and make a complete flight from takeoff, climb, cruise, descent, approach and landing. So I will show you all the phases of flight. So thank you very much for joining me in this video. I'm going to start now with the primary flight display. So you can see here we have about an hour left for this video to end. So you can see here the primary flight display. You can see also some other aircraft coming in. We can use this. Change the distance. Over here you will see a couple of aircraft are very close to us. You will see with the diamond shape. So you can see the distance they are located. Each one about 11 or 12 nautical miles in this range. One is plus 2,600 feet, the other is plus 9,900. You can see the direction where we are right now, our position. So we can see here we have the primary flight display. You can set also over here meters. So we have the airspeed indicated, the ground speed, the airspeed selected from the autopilot director system panel displayed with purple. You can see here the altitude indicator, the barometric pressure altitude 1,430 feet or 436 meters. The altitude selected from the autopilot director system panel and the barometric pressure of the outside atmosphere 29 to 92. The radio altitude 2 feet and the magnetic heading and part over here, magnetic north pole into north pole. So you can see it's either magnetic or geographic north pole right now for navigation. So we change back to the normal magnetic, and we have also inches of mercury of hectopascal. So we see 1013 hectopascal. You can see here the vertical rate of climb descent of the aircraft in 200,000 feet per minute. So you will see the needle moving up. The aircraft is climbing and the needle is moving down. The aircraft is descending. You can see here the other indicator, the pitch ladder indicates 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees of climb and descent of the pitch altitude in the flight. So this determines the pitch altitude, not the flight path. So you have to look at this indication to see whether the aircraft climbs or descends in flight. So you have also the airspeed and flight mode and theater, the angle of attack of the aircraft flight director. We can see here also the indications, the weather radar and the terrain reflections, as I told you. The elevation of the terrain, green, red and yellow and blue. And we have an aircraft coming in. It's about now plus 1,300 feet above the elevation of the aircraft, and it's the setting, the arrow down next to the diamond over here. The diamond represents this aircraft that is coming in here. So also now you will see the aircraft in front of you. Somewhere around here you can see a red beacon is blinking. So we're gonna have it, it's like 2.5 nautical miles away now from us. Plus you can see this smaller link which is a warning. We have an aircraft very close to us. It's plus 600. You can see the airport over here. We're gonna see the runway also. So we have plus 2.5 nautical miles, plus 500 feet. We're gonna have the traffic now, the warning here displayed using this aircraft. Plus 400, you will see it displayed with yellow now, plus 300. And we have the traffic is coming in. This is the traffic coming in. The aircraft just spotted over there. So it crosses by, you can see here. That's wanted, so we still have it everything in the navigation display. You can see the yellow and the traffic warning over here where the aircraft is located. So we have also the terrain, the airports. We're gonna have the flight management computer, also the data. You can see the green, yellow and red. So this is Switzerland, this is the airports of the Germany here in France. So you're gonna see also over here we have the auto throttle left off. You will see auto throttle left off over here. You turn off the auto throttle left, auto throttle right off. Over here you will see auto throttle right off. Over here flight director on and off. Flight level change. This is the airspeed. Select knob. We can change the airspeed. Flight director off. Turns off the modes which are already. So you can use the LNAV, the VNAV. So we'll set our airspeed for takeoff. Indicated airspeed mark. Line continues. So also we have the bank angle and the heading. So this is the main airspeed, the LNAV, the VNAV, the bank angle, decrease, select, deselect like this by pressing the switch in. So we can select by heading. I will select the runway we're gonna use, and you can select heading and track. The altitude also 35,300. Then we can select either altitude and flight level change with the heading over here. so we select one mode at a time. So we have the flight level change with the heading, and the flight director with this target airspeed 253 nautical miles, flight level change speed for this target altitude 7,710 meters or 25. So you can set, as I told you, 1013 hectopascals or inches of mercury, 39.92. So here change the barometric pressure. So we can set also the autopilot on, like this. You will see this mode now with the autopilot flight level change, autopilot connected, and we can have both flight directors on. So we have also the altitude here, select, and a couple more modes. So the altitude over here, it will display in this flight mode annunciator with the heading hold, and we're gonna have also the vertical rate of climb descent of the aircraft over here. The last one mode, we have the warlock also, and the approach, and we have the vertical speed, flight path. We can set over here a negative or a positive for climb. So you will see -3.5 degrees if you move the slider up or down, and you will command the autopilot and the autothrottle. In this right now the descent path, you can see the descent line over here is below the horizon line, so it's -3.5 degrees over here, this tick mark for the Boeing airplanes. So for all the Boeing airplanes, primary flight display is the same. So now we're gonna set the climb +3.5. So you can see the +3.5 over here. We change the slider up and down, also the heading, and the altitude, and this also the airspeed. So this is easy to memorize which one is which for the autopilot of the Boeing 777. I hope you like my Boeing 777-300ER airplane. So we have another positive over here, climb 3.5 degrees. You can see here +3.5 degrees, so it's a positive climb between the 2.5 and the 5 degrees. It's altitude indicator. So this is gonna determine the flight path, 253 nautical miles per hour, 35,300 feet target altitude with the SPA flight path angle, and this speed rate altitude. So you will see the needle moving up instead of moving down here in the vertical speed. So we can set also another mode. We're gonna set the vertical speed. We're gonna set vertical speed in 10,000 feet per minute, like -3,500 feet per minute. You will see the descent rate over here. So we have the descent rate now over here on -3.5 degrees over here, -3,500 feet per minute actually. So you see the needle moving down, descent commanded from this cruising altitude with the vertical speed, and also we can set our climb the other way. So you have the +3,500 feet per minute, and this is gonna give you a climb rate of 3,500 feet per minute with this vertical speed mode, target airspeed, target altitude, and the pitch. Also this is gonna be over here displayed with the purple arrow indication. So we have a few more minutes to go. So this is all in all the modes of the autopilot. So I'm gonna show you how to disengage. You see the autopilot is engaged, you press out this switch, you can see the warnings here, and the red warning, and you can see autopilot is disconnected with red letters. And you can see flight director here instead of autopilot, instead of AP. So we reset one more time, so you get the same thing. So you press in this and autopilot on. You see the warning is disengaged, so you see the red warning is lost from here. So we disconnect this time. We're gonna use this small switch over here. Press it one time with the control wheel, or you can press the control wheel around to take control. So you see again the warning and the autopilot is disconnected. So we have to press one more time the switch, and this will confirm the autopilot is disconnected, and we take manual control of the aircraft. So I will show you a couple more systems now and things you need to know about the Boeing 777-300ER before we start flying. So I show you the control column. You see the horizontal trim stabilizer over here, horizontal trim, the horizontal tail actually. As you can see here, the horizontal tail of the aircraft. You can trim the tail position up and down, or the rudder, or the ailerons and the spoilers. So we use more often the horizontal tail over here. You can set the pitch trim up and pitch trim down, pitch up and pitch down, aileron trim. So you can see the position of the horizontal tail trim over here in degrees. The green band is for takeoff, also nose down and nose up. And you can also use the trim tabs for trimming the horizontal tail up and down. You can see here the vertical tail, the rudder and the ailerons and the spoilers also. So also we have the auto trim system from the autopilot and flight director system panel. Has its own auto trim function. So I will show you also that. So you can see again another aircraft we just spotted over here. You can see it here in the radar display. You can see how far away is 10 nautical miles plus 2,700 feet, and it's coming in down here for landing also. So we'll see, keep tracking this aircraft. So you have the auto trim system, as I told you, from the autopilot and flight director panel for the horizontal tail of the aircraft, auto trim and manual. This is the manual trim. So in case of failure of the CODR hydraulic system over here, or the bleeder which pressurizes the CMDR hydraulic system, you're gonna lose the auto trim. Over here you're gonna have a failure, so you have to disconnect this trim. This open this guarded switch here, this red guarded switch open and turn off from the normal into cutout position the CMDR. You can see CNR hydraulic auto trim. So you will lose the auto trim only, but you will keep having the manual trim position of the horizontal tail over here up and down, and also the manual trim here. So this is for the trim of the aircraft functions, which is part of the flight controls. So you keep guarded switches closed. We have also the flaps position. I will show you now. You can move this handle up and down, which increases the surface area of the wings or decreases. You have the speed brakes. You can extend the speed brakes when you have the thrust levers at idle. So I will show you also that. So we keep having the aircraft in front of us coming in, very close. So we're gonna have the warning in a couple of it's plus 1,200 feet. You can see the radar display here, plus 1,100. Getting closer and closer, our aircraft in front of us. So you can see the blinking. You can see also, you're gonna see the traffic in a couple of you can see 1, 2, 3 aircraft right now in the navigation display. You have 2, 1, 2, 3 aircraft. flying around us. So you will see also we have the fuel control, the left and the right engine. So this is the thrust levers for the left and the right engine, and this is the fuel flow control. This is the fire extinguishers for the left and the right engine. Tells you the speed brakes, the parking brakes up and down. So we're gonna have the warning now. Here the traffic warning, and we have in front of us the aircraft that's coming in. So we had a good warning about that. You see now we know how to use that. So you can see the aircraft is coming in for landing over here. So we keep having 1, 2, 3 aircraft displayed in the navigation display. So this is useful also for flying. You can see the radio and communication panel. You can see the transporter. I told you a GSP and ADC transporter, transmitter, receiver here. You fix the function. Also the weather radar and the terrain reflections. We have the ADIRU, the air data inertia reference unit that displays all the air data, like the airspeed, the barometric altitude, the GPS position, the magnetic heading and track, magnetic north pole, and also the attitude of the aircraft, the laser gyroscopes that determine the attitude of the aircraft, and the angle of attack of the aircraft. So we have many functions using the small switch here, the ADIRU, as well as the GPS receivers and the coordinates. So we have also, I told you, parking brakes up and down, speed brakes, extend and retract. So you can extend the speed brakes when the thrust levers are at idle. If you have the speed brakes extended when the thrust levers are at idle, and you move the thrust levers forward, the speed brakes retract automatically. I can see the speed brakes. So also when you move the thrust levers at idle, you can move the thrust reverse, which extends also the speed brakes automatically. So you can see over here the thrust reverses, the left and the right engine. You can see the M1, and you can see the blocker doors here are open, and they deflect the flow of the air from the bypass fan of the turbofan with the engine. So you can retract them, and you can extend again the thrust reverse like this. Also the front side of the thrust reverses, you can see you can retract and you can extend again. So this is the thrust reverse function of the engine, you can see. So we have the thrust reversers with the blocker doors open. So you use this only when you land after touchdown in the runway, or you have a rejected takeoff and use this in flight. So we have the thrust levers, as I told you. Forward and aft position, you command the FAREX. We have the General Electric 90, G90 turbofan engine, so you command the N1, which is the low speed starter and sub-low pressure compressor and turbine of the turbofan turbocharged engine, the left and the right engine, the exhaust gas temperature per engine. You can see other secondary information related to the engine, like the flaps position of the lightning gear, extend and retract. I'll talk to you about now. You can see the exhaust gas temperature, you can see the bleeder, the pressurizer from the 5th and the 9th stage of the fan stages of the shaft of the turbofan turbocharged engine. You can see the lot of fuel on board the Boeing 777 for 6,600 kilograms, and the temperature right now of the fuel. The N2, which is the high speed starter and has the high pressure compressor turbine of the turbofan turbocharged engine. The fuel flow per engine per hour, 1,000 kilograms per 1,000 pounds, all pressure, all temperature, all quantity, and the vibration of the N2 stage of the engines indices. So you can see also, as I told you, if I move the thrust levers, I have also here is the auto throttle, disengage, disconnect switch. So you press this switch and you disconnect the auto throttle. You take manual control of the thrust levers. You have also the takeoff go round switch, left and right. You can move one thrust lever also at the time, so I will show you the differential. Thrust how it functions. If you have a failure of an engine, you will have to use one engine at a time, so you can use the right wing. You will see more thrust, 62% versus 31.9. You can move together and then leave the other side, the left engine. You can see also the warning that will not configure to take off, so you can see 49, 47, 48, 49. So you move forward off. So this will command the fatigue. So we have so for this Boeing 777-300ER airplane, we have the General Electric 90G90 turbofan engine installed. One the left wing, one the right wing for symmetrical thrust and redundancy. Each one contains a gearbox that contains the FADECs. The FADECs are full authorities electronic control computers. One installed per engine gearbox, dual channel redundancy. One channel fails, the other takes over. Controls, monitors, and displays all the data and the functions of the engine. You see like the M1. The N1 is the low speed starter and have the low pressure compressor and turbine of the turbofan engine. The N1, the exhaust gas temperature per engine. The N2, which is the high speed starter and have the high pressure compressor and turbine of the turbofan engine. The bleed air from the 5th and the 9th states of the turbofan engine. The fuel flow per engine per hour, 1000 kilograms, thousands of pounds. All pressure, all temperature, all quantity, and the vibration of the two states of the engine. So we have also the overpressure inside the engine. They can open the outflow valves into higher setting, so they can relieve the pressure from the engine. If we have an underpressure, they can close them into a lower setting, so they increase the pressure inside the engine. They also fuel flow to the engine, fuel metering unit, engine start, engine shut down. If we climb from the sea level to the cruise level, like 20, 30, 40,000 feet above the sea level, the air density, air pressure, and the oxygen level of the air becomes less than half of that of the sea level. Also, the airspeed of the aircraft is like 2 or 3 times faster than that of the sea level. So we have different fuel air mixture requests every second. So this is being adjusted by the FADECs regulated automatically. So we descend also the aircraft from a cruise level, vice versa to the sea level. We're going to have a different fuel and mixture request from the engines. Also the air intake from the front fans is changing, so all this is done automatically. So it's a good thing to have the FADECs installed into your engines. Now I'll talk to you about the newtons per second and the law of kinematics of motion, about the burning fluids, about the aerospace and aeronautical engineering. I derive some principles to use also for the for flying the aircraft, for the air transport pilot license. You need to know some things about how to fly the aircraft, about flight theory. So I will show you now a little bit. We have some time and then make the engine start demonstration. So you can see here the wings of the aircraft. They hold the weight of the aircraft when the aircraft is airborne, when we flying. You can see we have the vectors from the engine that propels the aircraft forward. The thrust overcomes the static and kinetic friction, and the lift from the wings overcomes the weight of the aircraft. Also, you can see the mineral dynamic core position, which is about 25% of the Mach. This is the position where the maximum aerodynamic lift occurs in the wings. Also, the position where the center of pressure, and also the stall starts above the wing. The airflow of the air mass becomes detached above the wing, so the aircraft stalls. Over here is the start of the stall. You have also the center of gravity vector that transverses the aircraft. Over here is the longitudinal axis and the lateral axis, and we have also the moment arm is times the distance from the center of gravity all the way back over the horizontal or vertical tail, over the airflow of the air mass per second, over the acceleration of the aircraft depending on where we are in the course. Then we have the moment arm that can pitch up the aircraft or descend. Moment arm and lever arm. This force from Newton's physics. Also we have the bottom surface of the wings. You can see using the Bernoulli theory of fluids, the airflow, the air mass is slower because the wings is more flat below the wings, so we have higher air pressure, which pressurizes the aircraft wings up into the air. Also you can see the top surface is having higher curvature, so the airflow, the air mass is moving much faster above the wings, which creates an air suction which sucks the aircraft weight and up into the air when we reach the takeoff speed. So this is all for the flight theory. Now we'll show you the overheat panel and make the engine start demonstration, show you the rest of the aircraft system and make the engine start demonstration flying this aircraft. So we have here, you can see overheat upper panel. You can see a nice view of the aircraft. You can see we have the hydraulic fluid disconnect for maintenance in the ground, the circuit breakers over here of the aircraft for reset of maintenance. We have the ADIO, the redundant reference unit, the primary flight control computers over here. The APU, we can start the APU with this, like this, you will see the fault. And this is the left engine, right engine, IDG, the great drive generator, 120,000 kilovolts or 120,000 watts, 100 ready to 200 volts, 400 hertz alternate frequency, direct current over here, the batteries, 30 volts, 48 ampere hours, the backup generators, and the APU also. We have the rammer turbine over here, the window heat, the passenger oxygen over here, the hydraulics, we can turn off the hydraulics, see what happens on the hydraulic pumps. You will see some warnings popping up, some fault messages in a couple of seconds. So here we have it. We turn off the hydraulics. We'll show you now all the systems of the aircraft. So you can see flight controls, primary hydraulic pressure, C, R and L are gonna fail, the stabilizer, and we have alternate flaps. So you can see all the hydraulic systems are lost. So we turn on again. You can see how well this is simulated. Back to the auto. So we have also the fire extinguishers for the cargo, the electronic engine control for the engine normal and alternate, the auto start system on and off. We can start the engines like this. We can dump some fuel to lose some weight and select the nozzles and the tanks and the quantity of fuel to remain. We have the left wing and the right wing fuel tank, and the center tank you can see is empty. So this is the fuel system and the fuel booster pumps on and off, and the crossfeed valves between the left and right wing. Wing and engine are the eyes here. You can see here is also the lighting system of the aircraft and the windshield wipers. So we have the auto start of the engines now on. The cabin pressurization here, automatic or manual. We need to use the outflow valves when climbs or descend to relieve the pressure or increase. Also we have the bleeder from the left and the right engine. Over here in the APU we need the APU bleeder to start the engines, you will see now. So you will see all the systems failing now, having the bleeder off. We're gonna lose the cabin pressurization and also some of the hydraulic pressure demands C1 and C2 here. So we turn on all the bleeder. So we're gonna leave this configuration now for takeoff. Also the flaps here, 15 degrees for takeoff. So this is a nicer view of the cockpit now. I'm gonna show you how to make the engine start. Only one part left here. The systems display. So we have the engine, the status. You can see the hydraulic, the APU, and the oxygen level. The normal menu, resets, normal menu, what to do. We have a failure, communication, navigation, synoptics. The doors are closed and the cabin can be pressurized. This is also the flight management computer. I'm gonna make a flight plan. The landing gear, you can see the pressure inside the tires and the temperature of the brakes. The electrical, I show you in the overhead panel. In the overhead panel, the left engine, right engine, as you see, backup generators, 38 volts with 7 volts. One charge, one ampere charge. The APU also running. You can see all the contactors. You can see the hydraulics here. 3000 psi, left engine, right engine, and the electric C1 and C2. Also where the hydraulic fluid goes, which is used hydraulic pressure, the quantity of hydraulic. This is the left wing, right wing, and the center tank. Total fuel in the left and right wing, empty center tank with yellow crosses. You can see the low and high pressure fuel valves in the left and right engine. The total fuel on board. Both engines are running, and the crossfeed balances the fuel between the left and the right wing. Also the APU is fed from the left wing using the DC motor, and you can see here the minimum fuel temperature below which the fuel freezes in flight. Also the air system, pressurizer from the left and right engine, the APU. Έλα. Τι θες? Θα πάω μετά σε αυτόν, 7 η ώρα και 7 και 4. Hey, 7 και 4, 7 και μισή κάπου. Κλείς την πόρτα μου. So we have here the pressurizer from the left and right engine, the APU. So you can see the pressurizer here increases when we move the thrust levers forward. So we need the APU to backflow into the engine starter. So we have the last section, the flight controls here. So you see everything is moving freely, and we have no failure here. Also this side. So this is the flight controls, the wings. You can see the tail, the vertical tail and the horizontal tail and the stabilizer. Everything is moving good. Going back into the mode. So we have to start the engines now. Make the engine start demonstration. So we're gonna turn off this switch here, left and right fuel. We're gonna see an overhead panel reset, and the engines here, engine auto start left and right, and engine shut down message. So we have this engine shut down, and both engines, left and right wing, are closing down the function. Also the fuel flow is 0 and the N2 is decreasing. So you will see only the pressurizer from the right and the left wing from the APU keeps spinning. So we're gonna have now to reset this the fuel flow back on, both left and right fuel flow. So you will see here the N2 increase very rapidly over here, and we have both engines, right and left wing. We have the fuel flow into the engines. So we are ready for starting the aircraft. So we left only one last step here. Menu, FMC, position initialize, Lszh, the reference airport, 0 fuel weight, reserves 5%, cruising altitude 35,300 feet, cost index 100%, minus 37, decrease Lszh, departure and destination. You copy paste departure, destination, airport runway 14, departure and arrival. So we're gonna select this departure. You're gonna see in the legs, and this arrival. Iris 14, transmit, you're gonna have the legs here, cancel the discontinuity, activate and execute. And we're gonna have the flaps position, center of gravity, and the takeoff speeds for this takeoff weight and this runway. V1 will rotate in V2, so we have all the legs ready, so we are ready for takeoff. We only need to taxi into the runway. Disarm the parking brakes here. So we need to go into the runway for advance the parking brakes off, advance the thrust levers. So we take the clearance, also use the tiller here for the nose wheel. So we take the clearance from the air traffic control and we are ready for takeoff. The runway is open for us, as you can see. So we need to align here with the runway using this tiller and the rudder pedal. So parking brakes on. You can see also the seat here displayed, LNAV on. The flaps are set, the horizontal trim stabilizer is set, so we increase the power of the engines, only decrease the maximum takeoff. You can see also the radar scan, so we are ready for takeoff over here. So we're gonna have this view for takeoff. Parking brakes off and full takeoff ground power. So we have 90 knots, 100 knots, 130, V1, we rotate. And V2, and we take off. So we have the positive rate of climb here. Landing gear up, keep climbing. So we have here, you can see we are 2,200 feet above the ground level, 2,400, but we are 4,100 above the sea level. We climb with 4,000 feet per minute. The airspeed is 213 knots. You can see the flaps limit here and the airspeed selected, the target altitude, and here is the flight plan and the terrain. You can see the mountains in front of you and the aircraft. So we have to cross these waypoints here as we climb. And we have this thrust and the autopilot there. So we're gonna have also the view outside. So this is the Boeing 777. So we have to make a small correction. So we keep climbing. You can see also the max speed 0.43. So we're gonna have some nicer view now outside over here, and we have 15 more minutes for this flight to complete. So we have this nice view of the Switzerland here, as you can see. And the aircraft, the Boeing 737-300 ER, as we fly with approximately 650 kilometers an hour right now, or 250 meters per second. So we have to keep climbing. You can see also the galaxy view. So here we are, another turn. You can see also the stall speed here, 15,000. So we need to trim up a little bit. So we have these waypoints here. Execute the first waypoint. We need to be overflying here. You can see also the stall speed, the warning here, 140, 135 is the minimum, the stall speed warning. So we have to cross this waypoint, the Zui, as you can see, Zui 4.1 nautical miles away from us. So you can see we are very closer to the stall speed, also zip line. Here 19,000. So we have to keep crossing over here these waypoints. Climbing maximum thrust and retract some flaps over here. So we have over here the Germany, the Bayern Munich in front of us, and the France on this side, and the Switzerland on this side. $31,900. So we are 32,000. Sorry. 89. So we're gonna have the handrails now and the contrary with the beautiful view. And we have 10 more minutes to go back to the airport. So you can see here is the Switzerland, this beautiful lake. Also the Germany, the Bayern Munich in front of us. So we cross over here with about the sky with about 250 meters per second. Then we have the chemtrails over here, the frozen vapors. And we are 3,100 feet above the sea level, as you can see. So we need to start turning. As I told you, we have the Germany and the France, and we need to start turning back home now. We have also the cruise level over here, so we need to retract the flaps to increase the airspeed and fly manually. Make a turn here as we keep level. You can see we tracked the flaps. This is gonna give us a pitch up trim as we turn. And we have the Galaxy, so this spacecraft for tonight, the Boeing 737-300ER. This beautiful airliner. So we fly with about 300 kilometers an hour, or 300 meters, about 900, excuse me, kilometers an hour, or 300 meters per second. 180 kilometers. So we cruise here very close to Germany, Bayern Munich, and the Switzerland, and also the France over here. We need to go back in. So we need also to connect the autopilot to hold the altitude of the aircraft, and select also the descent path now. I'm gonna have it. You can see the aircraft cruising with autopilot now. You can select also the approach speeds here with the flaps limit, and also the next legs we're gonna be overflying. So we need also to decrease the airspeed a little bit. Select a lower altitude, and the vertical rate of descent here. So we're gonna have descent flight path now. So we're cruising here. As you can see, this is our spacecraft satellite, the Boeing 777-300ER. Start the descent, and we need also to use the speed brakes which are idle thrust. So it's gonna give us some over speed. As we descend, you can see also the functions over here. So we have the AP on, like this, autopilot on. You can see the idle thrust, obviously commanded, and the autopilot panel. You can also have 13,000 feet, so we can extend the landing gear now as we are descending, and we are closer to the airport. So also use some flaps. So we need to align here. We have also the clouds, you can see, transition. We have the Lszh localizer here, as you can see. We can align with the runway, and so here we are descending, as you can see. We are almost aligned with the runway. Flying manually right now, as you can see. Having the thrust also commanded manually. So you can see here the Lszh localizer and the navigation display, all the indications. We are aligned with the runway, with the glide slope also as we descend. So it's gonna be idle thrust. Then, as that's done, parking brakes and reverse thrust, full reverse. We have full reverse thrust, and here we're slowing down. As you can see, the aircraft does touch down very nicely. So we made a beautiful lighting here. You can see all the nose wheel here is perfectly safe. There is